Hi, welcome. In this demo, I will show you the IV characteristics of lumped circuit components. Let's start with a simple resistor. This is a real resistor. You can compare the volume of this resistor with my fingers. And I will show you the IV characteristic of this resistor. This is a device called oscilloscope. It's mainly used for the VT graphic of components. You can see the voltage with respect to time. But with this purpose, you can use it to show the IV characteristic of components. For this purpose, I will apply some signal on components and show you the IV characteristics of components. Yes. Here what you see is a simple resistor, and here is the VI graphic of this resistor. X-axis is voltage, Y-axis is the current. And when you increase the voltage, current increases linearly. What you see is a linear line. It's called the resistance curve, and it shows a constant resistance to us. The resistance of this component does not change with respect to current or with respect to voltage. It's a constant line, and as you see, the resistance is V over R. And the next component that I will show you is a resistor again, but it's called an LDR. Its property is the resistance of that component will change with respect to light. For example, it has some resistance now. I will apply some light on it. Okay, as you see, this is my bulb. Look at the resistance line, please. You can see the increase in current. So R is V over I. V over I increases. It shows the decrease in resistance. With small voltage, there will be a higher current. When I make it dark, the resistance will increase, as you see. It's approximately open circuit. When it's lighter, when I apply some light, as you see, the resistance will change immediately. The next component is a kind of resistor again, but it has another property. As you see, it's a constant voltage now, but what I mean with constant voltage is the resistance does not change with respect to voltage or with respect to current. But as you see, this is my hair dryer. When I apply some heat on it, you will see the change in resistance. Yes, resistance decreases. When I make it cool, I release it to cool. As you see, resistance changes because its temperature is changing now. Then the other lumped circuit component is a diode, this one. And I will show you the IV characteristic of that diode. Yes. What it does is, this is high impedance line. It shows an open circuit. If you apply small voltages smaller than a threshold, a diode is an open circuit. But if you exceed some voltage, the current will immediately increase, and it's, as you see, approximately short circuit. It's a very, very low resistor now. So what diodes do is to let the current in one direction and to stop the current in the other direction. If you apply a higher voltage, higher than 0, if you apply a positive voltage, it will let the current flow. If you apply a smaller voltage, approximately 0, or if you apply a negative voltage, it will stop the current. Actually, if it were a silicon diode, this threshold voltage is 0.7. If it were a germanium diode, this threshold voltage will be 0.2. But in ideal diodes, we assume this threshold as 0 volts. And near this diode, there is another component, and it's called as LED. LED means light emitting diode. Its voltage current graphic, voltage current characteristic is very similar to the normal LED, normal diode, but it emits light when it has a current. But its threshold voltage is higher than the standard diode. I increase the voltage to show you. Yes, you see that for smaller voltages, smaller than some threshold, there is no current. It's high impedance, approximately open circuit. But when I exceed some threshold voltage, there is a current, and as you see, it has a very small resistance. And as you see, this diode emits light. Look at carefully, please. Can you see the change of light of this diode, light emitting diode? Look, it's changing. Its brightness is changing. It's emitting light. And the next component is a switch. I will show you the VI characteristic of a switch. Now it's in off state. It means it's open circuit. As you see, I'm applying different voltages, but there is no current. Guess what happens if I click this button? It will be a short circuit. What should be the graphic of here? Let's click on it. Oh, what you see is an approximately short circuit. There is no voltage change. Voltage is approximately 0 everywhere, and current change with very high negative voltage and very high positive voltage. And the next one that I will show you is a voltage source. Look, there is a battery here, 9-volt battery, and I will show you the VI characteristic of a voltage source. As you learn in theoretical courses, its voltage should be constant. Let's see what happens if we try to understand the voltage current graphic of a voltage source. Yes, this is what you see. Its voltage is an approximately constant value, but there is of course a small resistance, but it's not 0. It's very closer to 9 volts, and it has a very, very small resistance inside it. If it were an ideal one, this line should be 100% vertical. Thanks.